Get ready for a math revelation that shatters everything you thought you knew about randomness. We often picture randomness as pure chaos, utterly wild and unpredictable. But here's the jaw-dropper. True mathematical randomness is actually impossible to achieve. Why? Because every single mathematical formula is inherently deterministic. When computers try to fake randomness, they have to pull a trick, using our local time to generate algorithms. This means that even when we pick something that feels random, there's always a hidden rule in play. Think about it. If you prioritize the smallest integer, you get 1 for positive integers. For prime numbers, it's also 1. Systems that seem random are actually built on structure. But the real mind-bender, the cosmic mystery, kicks in when we dive into the realm of real numbers. This is the vast, unbroken continuum of all positive, negative, whole, fractional, and irrational values, stretching endlessly in both directions. Its infinite reach simply laughs in the face of any attempt to create a simple, step-by-step order. Seriously, try to pinpoint the number that comes immediately after 1. It's an impossible quest between the number 1 and literally any other number. There are infinitely many more waiting. We're talking 1.01, then 1.0001, then 1.00000001, and on, infinitely dense. This density makes sorting out next or previous elements in these continuous number sets an epic, overwhelming challenge. This colossal ordering problem within infinite real number sets wasn't just a quirky math problem. It sparked a monumental intellectual crusade that began around 1870, in the late 19th century. One individual, driven by an almost obsessive quest to map out a definitive sequence for these numbers, poured immense effort into the task, to the point of personal strain. It's a stark, dramatic illustration of just how incredibly difficult, almost impossible, it is to pluck a single, definitive element from an infinite, unorderable flow. It truly shows us that even something as basic as order can become a titanic struggle against the sheer immensity of infinity. The universe of numbers is so much stranger, so much more complex than we ever dared to imagine. Think about that for a second. The very fabric of numbers, the building blocks of our universe, contains paradoxes that challenge our deepest intuitions about order. If next is an illusion in the real numbers, what does that imply about how we measure and understand continuity? It's a wild thought, isn't it? The quest for order in the infinite isn't just a mathematical puzzle. It's a testament to the mind-bending nature of reality itself. The universe of numbers is far stranger and more complex than we ever imagined.